The instant your boot leaves the wet grating, the basin stops being a machine below you and becomes the only world that matters. You hit the water expecting the familiar push that brings a swimmer back toward the surface. Instead, the water feels broken. Your first kick produces motion, but not control. The surface is inches away, then suddenly farther than it looked. A strong swimmer usually trusts rhythm: breathe, pull, kick, rise. Here, every part of that rhythm is being disturbed at once. This is a hypothetical accident, but the equipment is real. Diffusers release compressed air near the bottom to mix water and transfer oxygen. Those bubbles do more than make the surface foam. As they rise, they drag surrounding water upward and build a powerful circulating plume. Water pushed upward must go somewhere. At the surface, it spreads outward, while return flow can develop around the rising column. That circulation is the first reason the viral phrase, "water with no buoyancy," is too simple. The danger is moving water, not magic. Air mixed into water can reduce the average density of the mixture. In some conditions, that means less upward support for a floating body. But laboratory work also shows that rising bubbles can drag water upward. Whether an object sinks depends on the plume, the shape, and the gas concentration. For a person, the practical question is not whether buoyancy disappears completely. It is whether the body can stay oriented and reach an exit. Your clothing is already filling with water. The tool belt that felt ordinary on the platform now pulls at your hips with every kick. The hard hat is gone. One glove is half off. Small losses begin to matter because they interfere with grip, breathing, and attention. The loudest sound is not your voice. It is compressed air, water striking concrete, and the mechanical roar of the blower system. Calling for help may be necessary, but every shout costs breath. The basin is open, yet the machinery makes it feel sealed. The next instinct is to swim straight upward as hard as possible. That works in calm water, but here it can become an energy trap. Vertical thrashing keeps the body in the most aerated zone and spins oxygen faster than the lungs can replace it. Panic also narrows vision. The latter may be visible, but a frightened brain keeps returning to the same useless movement. Up, down, up again. The safest response begins with a smaller goal. Protect the airway, slow the breathing, and stop fighting every movement of the water. This does not make the basin safe. It simply preserves the one resource that cannot be replaced inside the water: usable energy. Now you look sideways instead of only upward. The bubble field is not uniform. The water near the perimeter may be less violently aerated. A diagonal movement toward calmer water may require less effort than trying to climb vertically through the center of the plume. The basin wall is not rescue by itself. Smooth concrete offers almost nothing to hold, and a vertical wall can turn survival into a waiting game. A seam, pipe bracket, cable tray, or ladder rung changes the problem because a fixed object does not move with the current. Your fingers close around a bracket. For the first time since the fall, the water moves while part of your body does not. That grip buys seconds, not safety. Wet gloves reduce friction, the forearm is tiring, and the nearest ladder is still beyond reach. The tool belt must go. Releasing it underwater is awkward, but carrying unnecessary weight is now a worse risk than losing equipment. The belt drops. It does not vanish into darkness. It sinks through clear water, reminding you that the basin is deeper than it appeared. With less weight, the body sits slightly higher, but the improvement is small. The current and exhaustion remain the dominant problems. Across the basin, someone finally sees the missing hard hat and the movement at the wall. Recognition starts with an object out of place. The correct rescue does not begin with another person jumping in. An unprotected rescuer can become a second victim in the same circulation. The first priorities are alarm, flotation, align, and if the system can be stopped safely, ending the source of the turbulence. Inside the blower room, the operator reaches for the shutdown control. Air pressure does not disappear the instant a switch is pressed. The pipes still contain compressed air. Bubbles continue rising while valves close and the machinery spins down. At the wall, your grip begins to fail before the aeration does. Waiting is now a physical task, not a passive one. A life ring lands close, but not close enough. In turbulent water, a meter can be the difference between a tool and a decoration. Reaching for it means releasing the bracket. The decision is simple to describe and difficult to make with tired hands. The better option is to ask for the line to be pulled along the wall, bringing flotation to the grip instead of forcing the swimmer back into open water. The ring reaches your shoulder. One arm goes through while the other remains on the bracket. Flotation does not cancel the current, but it reduces the effort required to keep the mouth above the surface. The blower slows. The dense white column breaks into uneven patches, and the surface begins to behave more like ordinary water. This transition can be deceptive. Residual circulation remains after the bubbles weaken, so the team does not rush the extraction. A retrieval pole reaches the ring. The worker is moved along the wall toward the fixed ladder, not dragged across the center of the basin. The ladder is the first true exit, but climbing after prolonged treading demands strength the legs may no longer have. Rescuers keep the line under tension while you place one foot, then the other. The sequence matters more than speed. Once the chest clears the water, gravity returns with full force. Saturated clothing turns the final meter into another test. The worker reaches the platform, but survival is not finished at the edge of the basin. Cold stress, inhaled water, contamination, and delayed breathing problems can appear after an apparently successful rescue. If the basin contained wastewater or chemicals, exposure would add a separate medical emergency beyond the drowning risk. The incident review begins with an uncomfortable fact. A guardrail, flotation vest, non-slip surface, or lock procedure could have prevented the fall. Industrial basins are treated as drowning hazards for a reason. Rescue equipment and buoyant work protection exist because swimming skill is not enough. So, would the bubbles make every person sink instantly? No. The real answer depends on air concentration, circulation, body position, clothing, exits, and rescue time. Could a strong swimmer survive? Yes, under the right conditions. But strength alone is not the factor that decides the outcome. Survival came from recognizing that normal swimming had stopped working, conserving energy, reaching a fixed object, and allowing a controlled rescue. The most dangerous water may not look deep, dirty, or violent. It may simply obey a set of rules you do not understand yet. And that is the final test. Not whether you can swim, but whether you can recognize when swimming is no longer the solution.